Okay, hello people. Um, it's been a while since I posted something on this channel, maybe even a couple of months. I had reasons for that, and I will try to come back and make videos on a regular basis. I was trying to learn a new programming language, and I wanted to fix things at a university, but hopefully I have everything under control so I can focus on programming and C++ and the things that I'm interested in. This one's going to be short, and I wanted to introduce you a new programming language. You might already know it, and it might be interesting for some people around, but this is Go. And I'm just trying to get used to it, trying to observe it from different perspectives, see what it can, what it cannot. I've heard that this language is specifically good for writing distributed systems and services, and I will try to get to that point, but as with everything else, you have to build up your knowledge step by step. I was trying to implement a worker pool. So basically, when you have some task that you want to distribute between different threads, in Golang it's Go routines, and we might talk about it later if somebody seems to be interested. But and the task of worker pool is basically to receive tasks and schedule them for workers to execute, and those workers who stay idle, they can pick up a task and start the execution, and once there are no tasks left, the work considered to be done, right? And in this video, and I needed a thread safe queue. There are a couple of implementations. You can do it in Golang, but I needed to implement a thread-safe queue first. And that's exactly what I want to talk about. Go through the code, and maybe for some people it would be useful just to receive the first grasp on the language. So yeah, I have a couple of files. So basically it's q.go. And let me quickly, okay. So it's a q.go, and the file qtest.go, and I will put a link in the description as usual. So what we have is a core data structure, and those who are familiar with C programming language or C++ programming language, it's pretty much the same. That's how you define a struct, right? Yes, so the data fields that I have here is and I wanted to mention that it's not like a simple queue. It is a ring buffer. So when you so basically your front and back pointers, they can wrap, and instead of running out of space, they can just insert from the beginning. But this is a growing ring buffer as well. So you allocate some specific amount, some specific capacity, and the default value is 64. And then on the queue creation, you can specify the capacity on your own here, or the default capacity will be used when you do the first push to a queue. So yes. And for those people who are not familiar with ring buffer and the queue in general, I recommend the book. It's called Data Structures and Algorithms Analysis in C++, and it contains a lot of useful things, like it's C++ specific, but it covers the queue data structure and specifically the ring buffer. I'm really into books and I love reading them. So yeah, that's basically it. So this chapter will cover everything regarding about queue, how it works, how to use back and front pointers, and then you can see that the back pointer can wrap. So the back pointer is responsible when we add elements to a queue, and the front pointer is responsible, or rather in this case, it is an index when we pop elements from a queue. And when we run out of a capacity, the back pointer just wraps, and the same can happen for the front pointer. But anyway, that's how the implementation looks like. If the user specified the number which is not power of 2, I will round that to the next number which is power of 2. I use a couple of functions here, like to determine whether the specified integer is a power of 2 or not, and then I use this function to round to the next power of 2. I'm using the mutex because all the operations on the queue except those which are private, and we will talk about it later, should be wrapped in the mutex. So basically when you get a capacity, and it is an interesting question because in Go programming language there is a notion of there is read-write mutex. Read-write mutex, and basically maybe I should have used this mutex here instead. So when multiple threads access the capacity, they just use read lock. But it isn't clear because what happens if while we accessing the capacity, some other thread tries to push an element into a queue, and then we receive incorrect data. So yeah, that's basically why I decided to go with a regular mutex here. But you can experiment on your own and write some tests. So the capacity, the size returns like the size of the queue, then whether the queue is empty or not, how many elements left. So basically, if we push in elements into a queue, the left returns how many empty spots left, right? Push function, we will talk about it, and we have to lock pretty much in every single function. And the first statement is what it does is defers the execution of a specific function when we escape the scope of this function. So it's basically like a destructor in the C++ world. We grow the buffer here, and then we do some operations, right? Try pop, we're trying to pop the value, and we provide a pointer, and that's why I really enjoy programming in Go, because it has like support for pointers, and so you can be close, you can be as close to memory as you want, and it's pretty nice language. So you unlock the buffer, you lock the mutex, and then unlock won't be executed here, but right after we execute this block of code. So we what do? We get the front element, we put it into the value with the reference, the pointer, and then we create a 0 value, and then we initialize the front element with this 0 value. And again, it might be not necessary because like we still operate on indices, right? We operate on the back and front indices, so it might not be necessary. That's all right. It's just for because in Go the values are default initialized. If you create a struct and you don't initialize some values, for example, like I do here, I initialize capacity and the buffer. The rest of the members will be initialized to 0. And that's how the language works. Yes, try pop initializes 0, and then I increment the front iterator. It's basically an iterator, but since I cannot just front plus plus because that can. Since I told you before that it is a ring buffer, we need to wrap the front pointer. So if we reach like the capacity, we have to come back to the beginning if we still have some empty spots at the beginning of a queue. And then we return true or false depending on whether we were able to pop an element from a queue or not. And we have a pop function which does pretty much the same, and technically we could have collapsed them into a single one and put the functionality, like the common functionality, in a separate function and then use them. You can see like clearly that can be extrapolated into a separate function. But the difference is that we panic when we try to pop an element on an empty queue, and we have to lock as well. Front, it just gets the front element, and again we panic, and panic is basically an assertion in the C++ world. So you just if the queue is empty, obviously we cannot pop on the empty element. We just have to panic. Otherwise, we return the element, the front element. Yes, and we don't pop here, so we just get the element back, the copy to the element back. The back function is so it does the same but return the last element, and the back always points to the location where we are going to insert the next element. But since we cannot return directly that location because it will be empty, we have to subtract 1 from the back pointer, or if back is 0, we have to subtract 1 from the count because most likely it's wrapped. Replace is just you provide an index and you provide an element, and what replace does is just replace that element with an index. So like nothing, replace like a specific element in a queue by the index with the element that you specified. And again, there are a couple of conditions here. If you are trying to replace an element on an empty queue, that will panic, and if the index is greater or equal than the amount of elements in a queue, that will panic as well. That's like the design decision that I made. Otherwise, we have to find the right spot based on that index provided, and we have to iterate in a for loop, and then we just insert the element. A clear function clears the queue and it invokes 0 members, and again it's not even necessary because we can we operate in front and back pointers, so we kind of can avoid it. It's not necessarily, right? Queue count, again, if we just return if the queue count is 0, which means that the queue is empty already, we don't have to do anything. Flush is, what it does is, as I showed you before, the data type constitutes of the buffer, and in Golang world it's called a slice. So basically it's basically as a std vector but without any messages. It doesn't have like pushback size and some other, and plays back insert. It doesn't have all of those messages, but the notion is the same. And what a flush does, it just provides a result, and you don't like note that you don't have to pass it by pointer. You pass it because it will be passed by reference, and you copy all the elements to that result, and you have to synchronize here that you have to make sure that the length and the capacity of the buffer that you're providing is exactly the same that we have here, right? And here I check whether it's nil or like the count is equal to 0. And in this situation, I just return. And So, and this is really important, this piece of code here, because we check if the queue back is greater than queue front, which means that we never wrapped the pointer, the queue is aligned, right? So we have like front pointer here and the back pointer here, so we just have one chunk that we need to copy, and that's what we do. Otherwise, a back pointer will be either equal to front, in which case we have one element, or it is less than front, in which case we have two chunks from the front to the capacity and from the beginning of the buffer to the back. And that's why we do two copies here. We first copy from the front to a capacity into result. That would be the first chunk. And then we get the amount of copied elements. And then we specify that, okay, on the result, please start inserting all the elements from uncopied, and this is like the contents, the actual elements that you have to insert into the result. And then what we do, we call zero members, and we will get to that function later. Then we have grow, which is really important. This function is responsible for growing the capacity, and the capacity is always grows to the next power of 2. So if the capacity, the current capacity is 8, next going to be like 16, right? So this is how we specify the next capacity. We allocate memory. In Golang, you have to use the keyword make here, and then what you do is and basically I checked whether, like, if the capacity is 0, then we specify the minimum capacity, and we allocate the buffer of that minimum capacity. T here is basically a generics, the same thing as you do in C++. If you specify like a template, that's exactly the same in Golang. So T can be anything, an object, a pod type, it can be anything. If queue count greater or equals than queue capacity, we check whether we need to resize the buffer, and we do that. And again, the same piece of code. Probably I should have collapsed that into a single function which does this check and copies the buffer, because right now we have like a small duplication here and here. And then we have to reassign all the indices and the capacity and the buffer itself. So we assign new capacity, we assign new buffer, and queue back equals queue count, the amount of elements that we have, and queue front equals 0. So we have, like, if previously we had 2 chunks, right now we have one single chunk and an additional space for appending new elements into the buffer, into a queue. Next index is basically computes the next index, and it takes into consideration that while incrementing index, it can wrap. So that's it. And 0 members, what it does is allocates memory for a new buffer. And I've made a command here that is probably not ideal approach, but we have to. It's not. Like the way how it is implemented, we allocate memory, and then memory is we allocate a buffer, and that buffer is 0 initialized, and we copy that buffer to the buffer that we had previously, and that's how we just flush it. But we could have used like a flush function or whatever, and then we reset all the indices and the count. Maybe this is not necessary, and that definitely impacts the overall performance that we have, but that's how it is currently. And then I have like some tricky functions for computing rounded number to the next power of 2, and this last trick is just computes checks whether like the number is power of 2 is a power of 2 or not. So we just subtract 1 and we add with the previous number. And if the result gives 0, then it's that is a power of 2. Otherwise, it's false. And for 0, we return false. For this guy, I will put link in the description so we can read about like the implementation. Yes, and I wrote like a couple of tests. So I will introduce you the way you do tests in Golang. So there are some helpers here. First of all, you have to name a file q_underscore test.go or whatever. That's how your test would look like. And you put your functions should start with a test. And as a single argument, you should accept a pointer to a test in T. And I used assertion package because I used to do it in C++ with Google Test. So we just use an assertion package. And yeah, so let's take a look at the first test. We create a queue of type string, we push element, and then we check that the capacity is equal to minimum capacity, the size is equal to 1, and the indices are correct. The helpers are like pop n and push n. So basically those are generic functions which accept a queue, and they accept the n, which is the number of elements that we want to put into a function, and that we want to put basically into a function, and then they accept the lambda procedure, which basically a function that computes an element that will be inserted and takes an index, which in this case will got to be I. So you see I'm calling the function here. So I just insert an element that returned from that function. Pop n, what it does is just the same, but it pops an amount of elements from a queue and it returns the result. It accumulates the popped result and it returns it. Aggregate struct is just so we not only operate on integers and strings, but we operate on aggregate types as well, like integer and string together combined. And I could have included like channels because they are pretty common in Golang. Yeah, so things like that. Obviously, I have more complex tests, and we can talk about it briefly, but I'm not going to mention all of them. There are some tests for wrapping like a front index. We can iterate over, like you see when we insert some amount of elements, front and back indices point to the same element. But when we pop, after popping like n-2 elements, the front goes forward, leaving back pointing to the first element. Yes, so that's how you structure your tests in Golang programming language. There are some things that I commented out. I have tried to play around with multi-threading in Golang. And it is like it's not complete implementation. I'm just trying to get used to the language and be comfortable with this, trying to understand how it works and how to write programs in this language. Yes. Yeah, maybe we can take one more task and go through it. I don't know which one would be the most valuable. So here we test in like a flush function. We create a queue and we don't specify a size. Here, so the capacity is 64. Is it intentional? Probably yes. We push some amount of elements, and this is the lambda that will be invoked to compute an element that we are trying to push. Then we have pop n, then we have like, then we pop some amount of elements, we again push elements into a queue. And the reason why I told you before, like why do we need those helpers? So we will be able to compare the final buffer that we have in the queue with the result of all the pushes and pops that we had previously, because they return both results and we can combine them and build the buffer that we expect from the queue. So, for example, here we have like we do copy twice. The first is from result, some amount of elements, and the second is from the result number 1, but from starting from a specific index. Yes, and single try pop. So basically, like, I introduced tests for every single function that we have in a queue, and integrational tests as well. A push pop, so we pop an amount of we push an amount of elements, and you see here we specify the queue of a capacity n, which is exactly 8 elements, not default, because the default will be applied only when you when you don't specify the capacity initially, but then after the first push, minimum capacity will be set automatically. And yeah, we push, we then use front and back functions, and then we use some pop operations to get the element back. Force to grow, I'm trying to grow the capacity here, and I'm using this ellipsis operator, which basically, if you program a lot in C++, it's template parameter pack expansion, but template parameter pack expansion, but what you can do is in Golang, so you can get all the elements returned from push and function and append them to the result. So that's how it is, and yeah, I don't think that I have anything else to say. If you're interested in Go programming language, or learning this language, because I'm definitely interested, I want to know more about it, and I will be posting some videos on this channel about Go programming language. So yeah, I will definitely put the code that I wrote in the description, so you can take a look and play around with it. Because as I said before, the reason why I created this data structure is Go doesn't provide you a queue initially. It only has a slice, and you just wrap it in some kind of a custom struct, and add some methods on top of that in order to make a queue. So yeah, I hope that was interesting to me. I will try to stick with the schedule and release videos every weekend. I'm not gonna promise anything right now because I have a lot of things to do, and we'll see, but I will try to find time and make some interesting programs as I learn the language. Thank you for watching, and have a good day.